The lesson topic for this video is graphing parabolas using all characteristics. All right, so here we go. We have two examples. I have the first one here in vertex form. This is the form that has parentheses. And on the next slide, we have one in standard form. Same process for graphing a parabola when, no matter what form you have, is that we need to find some information. We want to find our x-intercepts, our equation for the line of symmetry, our vertex, and our y-intercept. So remember, we've talked about this already on the previous lesson. To find x-intercepts, we want to find the value of x when y is 0. And remember that you have a couple different things that can happen here. We can have no x-intercepts, one x-intercept, or two x-intercepts. To find that, obviously, if you start by writing this out, saying I want to find x when I know that y is 0, this might help you remember that what we need to do here is put a 0 in for y. All right, so we're going to come over here and put a 0 in for y. And we'll write the equation, and then we need to solve this for x. Remember to think about the process for solving. In this case, we have the parentheses, it's in vertex form, so we're going to solve by undoing the PEMDAS steps. And we get -9 equals -2x minus 4 squared. And these cancel. Next, we're going to divide both sides by -2. This is 4.5 equals, those cancel, x minus 4 squared. So we've done this solving before, but this is good practice. We're going to square root both sides of the equation. When we square root both sides, do not forget that we need plus or minus with our square rooted answer. And we get 2.121 when we square root 4.5. And lastly, we get rid of what was in the parentheses because we're undoing the PEMDAS steps. So we're going to add 4 to both sides. And these cancel. We're going to get x equals positive 2.121 plus 4. Or we're going to get x equals negative 2.121 plus 4. So we need to find those two values. The first one is 6.121 when we add them. And we get 1.879 when we round that correctly. So those are our two x values and y is 0. When y is 0, 6.121 and 1.879. So those are my x-intercepts, and we're going to go ahead and put those on the graph right away, and we're going to do our best to estimate this. It's just a little bit larger than 6. So here's 6 point approximately 1. Don't worry about being don't worry about the 1.121 because it's just a little bit beyond the 6. And then 1.879 is just shy of 2, which is going to be right in here. Now, what do we do next? Well, we look at what our equation for our line of symmetry is. Okay? Equation for our line of symmetry, we are going to find by doing the following. Think about these 2 points right here. Okay? We know that the line of symmetry needs to go directly in between those 2 points because these points are going to be symmetric around that line of symmetry. So if we have to find the middle point between these two, what are we going to do to find our line of symmetry? Well, we are going to find the average of these two values for x. We're going to find the middle. So we're going to add the two x values and divide by 2 to find the middle, like we've found averages since elementary school. So what we're going to do here is we're going to take our two x-intercepts, 6.121 plus 1.879, and we're going to divide that by 2. Okay, we're going to take these two values for our x-intercepts and we're going to find their average. So add them up and divide by 2. When we do that, we're going to find the answer here is 4. Okay, so what is our equation for our line of symmetry? The equation for our line of symmetry is x equals 4. So if we look at our graph up here, we can find the value where x is 4. We're going to find that right here, and we know there's going to be a vertical line for our line of symmetry at x equals 4. So that's a new piece for this lesson, and it's pretty important. understanding how we find that line of symmetry, and it's simply by averaging our x-intercepts to find the middle. All right, now somewhere on that line exists our vertex, somewhere on this line, okay? And our vertex, if you remember from the previous lessons, our vertex always has the same x value as the what? As the line of symmetry. Because if our vertex is here, the x value is 4, right? If our vertex is here, our x value is 4. What if our vertex is here? Our x value is 4. We know our x value of our vertex is always, always, always the same as the x value of our line of symmetry. So we can take this 4 right here that we found and put it in for our x value here. Now, that means we know the x value of the vertex. And remember, what we do in this class, when we know the x value, we can find the y value by simply using trace. So go ahead and put this into your graphing calculator if you haven't already, and use trace 4 to find your y value for your vertex. Okay, and when you do that, you hit trace 4, you're going to get 9 for your vertex. So, for the y value of your vertex. So we know the vertex is at 4, 9, which is 4, 9 right here. There's our vertex. Kind of a sloppy point there, sorry about that. And the last thing we're going to find is we're going to find our y-intercept. And if we find our y-intercept, we do that again by thinking about what is a y-intercept. It's the y value when you know x is 0. So again, we just used our graphing calculator and we did trace 4, right? We did trace 4. Now we're going to go ahead and do trace 0. So go ahead and use trace 0 to find your y-intercept. And for that, you're going to find negative 23. Now, negative 23 is not on our graph coordinate plane right here. As you can see, it only goes to negative 10. But if you picture it way down here, would that make sense, way down here, for the parabola that we're about to draw? And the answer is yes, it does make sense, because this parabola is going to be drawn from the vertex down through, through our x-intercept, and it will continue to go that way. And then from the vertex through this x-intercept and continue to go that way. And so way, way down here somewhere, it will hit negative 23 on the y-axis. So that looks good. So again, finding our x-intercepts is the solving skills you learned in many previous lessons. The line of symmetry is pretty new here. We're going to find that by averaging our x-intercepts every single time. Once we find that line of symmetry and draw it in, we know our vertex will have the same x-coordinate, so we just use trace 4, and in this case we use trace 0 to find our two y values, and we plot those to graph. Okay, so for our second example here, we are going to use the same exact process, but this time our equation is in standard form, not vertex form. We're going to start though same way. We want to find our x-intercepts, and there might be 1, there might be 2, or there might be no x-intercepts. So we're going to go ahead and put a 0 in for y to find our x-intercepts. And we're going to look at this and think about our solving skills. We're not going to solve by undoing because there's no parentheses. So to solve by factoring or quadratic formula, we first look for a GCF. There is no GCF with 3, -2, and -5, so then we look to see if it's factorable. So our magic term here would be -15x squared, right? And we do know that the factors of 15 are 1 and 15, where one of them would have to be negative. Sorry, that's kind of sloppy up there. Or 3 and 5, and one of them would have to be negative. And then we see that 3 and 5 is going to help us, but we need a -2, not a +2 when we add them. So we're going to switch our signs, positive there and a negative there. So these two multiply to give us -15x squared, and when you add them, you get -2x. So it is factorable using magic number. So 0 equals 3x squared. And then our -5 over here, plus 3x minus 5x in the middle. By the way, if you don't like factoring, you could have used the quadratic formula right from the get-go on this, using 3 for A, -2 for B, and -5 for C. and use the quadratic formula if you are more comfortable with that. I'm going to continue factoring, so I'm going to bring that 0 and the equal sign down, but I'm going to factor out the 3 and the x. And when I do so, I'm left with x plus 1. And I'm going to factor out a negative 5 over here, and I'm left with, again, x plus 1. And our parentheses match, and that's good. We have x plus 1 for our matching parentheses, and we have 3x minus 5. Our 0 equals in front. And now this tells us we're going to use the zero product property to solve for x, because the two things are being multiplied together, and we get the answer of 0. So that means either x plus 1 must equal 0, or 3x minus 5 must equal 0. Solving these, we get x equals negative 1, or adding 5, we get 3x equals 5, and we divide by 3. We get x equals 1 point, well, it's 1 2/3, so 1.667. All right, so we've got negative 1, and we've got 1.667 as our two x-intercepts. So we're going to go ahead and plot those on the coordinate plane. So here's negative 1, 0, and then 1.6670 is 1 2/3, which would be right around here. All right, so our equation for our line of symmetry. We talked about that in the previous slide, that what we're going to do is we're going to add the x-intercepts, and we're going to divide by 2, because we're trying to find the middle, or the average, between the two x-intercepts. So when we do that, we get 0.333. So we're going to get x, whoops, sorry about that. We're going to get x equals 0.333. So there's the equation for our line of symmetry, and we're going to go ahead and again draw that in as best we can on this coordinate plane. So it's at 1/3. Sometimes it's a little tricky to draw in a vertical line at 1/3, but that's pretty good. Now, think about that. It's at 0.333, or 1/3, and is it in between, directly in between these two blue dots? Yes, it is. It's right in the middle. So it looks like a good spot for our line of symmetry, so we must have computed that correctly. And now we need to find our vertex. Remember, to do so, you can put that same x value in for the x coordinate of your vertex, so 0.333, and we need to find the y coordinate. Again, using your graphing calculator, use trace 0.333 to find the vertex, and while you are at it, you can do the same thing for your y-intercept, all right, because a y-intercept is when x is 0, and we're going to try to find that y value as well. So again, using trace to find both of these answers. Go ahead and do that. All right, so for the first one, we get negative 0.5, I'm sorry, negative 5 1/3, or negative 5.3, repeating. Okay, and for the second one, when x is 0, we get negative 5. So there's a couple of points that we can now plot. Our vertex is at 0.333, which is on the line of symmetry, and then negative 5 1/3 will be approximately right here. And then would that make sense that our y-intercept is at negative 5? It sure would, because that's right here. And the parabola will go ahead and curve the way we need it to from the vertex through the y-intercept, through the x-intercept, and increasing. And same thing symmetrically on the other side. Ask if you have any questions in class about this process.